video, I'm going to go over examples from factoring expressions 3. Now, what looks different from the expressions you see today is that you generally will see 4 terms in an expression. And at this point, I generally will already have them in standard form. The highest exponent first, so exponent of 3 in the variable, of 2, of 1, and when you do not see a variable, it's x to the 0. So 3, 2, 1, and 0, this is in standard form. How do you know when to use this method? When you have 4 terms right now in your math career, often we will be able to use, it's called factoring by grouping. Please write it down, factoring by grouping. And just like the other 2 types of factoring we've learned, which is factoring binomials and the sum or difference of cubes, factoring is just another way to rewrite an expression. So it's another way to write an expression that is equivalent, just in a different form. So because we already have it organized in standard form, I'm going to underline the very first 2 terms. And I'm going to first look at the numbers in front of the variable. So I'm looking at 5 and 1. And I ask myself, what is the largest number I can factor out of 5 and 1? The answer is 1. Then I look at x cubed and x squared. So again, if you're a visual learner, that means 3 x's and 2 x's. And I ask myself, what's the maximum number of x's that I can take out of the first group and the second group? And the maximum number of x's is 2. Now we're going to use the concept of distributing in order to find out what should go inside of the parentheses. So whenever you distribute, you multiply. So this is what my mind is thinking. 1 times what number gives you 5? 1 times 5 is 5. I need to end up with 3 x's when I distribute. I have 2. To end up with 3, I need 1 more x. So I know I've done this right when I go, okay, 5 and 3 x's. Perfect. 1 times what quantity is negative 1? 1 times what quantity is negative 1? If you write 1, it's wrong. You have to put a plus or minus here. In order to end up with negative 1, I need to put a negative sign in front. 1 times negative 1 is negative 1. I need to end up with 2 x's. And when I distribute, you can see I already have 2 x's. When I distribute, I already have 2 x's. Awesome. So I've just taken care of the first 2 terms. Now whatever is in parentheses, we're going to pretend like this is a computer, and we're going to copy this, we're going to highlight this in our minds, and we're going to copy it and paste it in back. Leave space here. Copy it and paste it in back. And then really lightly, I want you to put a question mark that's dashed. Something we can write over the top of. Very, very light. We're going to do the exact same thing. I want you to circle the next 2 terms. If there's a variable, make sure to circle it with it, and if there's a sign in front of a number, it needs to be circled as well. So don't circle 25x, circle positive 25x. Don't circle 5, circle negative 5. If this is factorable, there is a magical number that I can choose, that when I multiply by distributing, I get positive 25x, and that same number when I multiply times negative 1 gives me negative 5. So this is what my mind's thinking. What number times 5 gives you positive 25? If you write down 5, you're wrong, because there has to be a sign in front of it. So what sign should go here? So 5 times 5 gives you a positive 25, a positive sign. Now we need to check to see, did I choose the right magical number? If no magical number exists, we can't factor this. It's not a factorable expression. So here's how I check. Okay, is positive 5 times 5 positive 25? Yes, and I need 1x. I have it. Now I'm going to check the next number. Is positive 5 times negative 1 negative 5? It is. Good to go. All right, so there's 2 steps left. I want you to think of this as like a midline or a half court or a 50-yard line, and I want you using your pen or pencil to make a pretty bold vertical line that separates the front half from the back half. When we factor using this form, we are consistently going to see that we have these parentheses in common. That's going to be consistent. So I'm going to take whatever's in parentheses and I write it down only one time. Only one time. And then I'm going to put an open parenthesis in back that I'm going to fill in. The mistake I see students make is they're going to write this down twice. They're like, well, I see it twice. Write it down just one time. Now, what goes in back in order for us to rewrite this in an equivalent form? We ask ourselves, what's in front of the first parenthesis? 1x squared. Got it. What's in front of the second parenthesis? If you only write 5, you're wrong. What is in front of the first parenthesis, or the second parenthesis? Positive 5. Now, we've done everything. The very last part is we're going to ask ourselves, can we simplify this further? Can we simplify this further? So, can I divide something out of 5 and 1? No, I can't do anything. And now I'm just going to go off to the side, and we're going to do a quick review of Tuesday. Really quick review of Tuesday. Okay, ready? So you're welcome just to watch this. This is going to be when we talk about the difference of squares or factoring binomials. So can you take out that pink piece of paper? Would you grab me a pink piece of paper, please? If you don't have one, run to the back, grab a pink piece of paper and put it back when you're done, please. But go into your backpack, grab a pink piece of paper. If you don't have one, grab it in back. And I'm going to ask myself, can I factor this? We're going to take just a quick second to review what we learned on Tuesday. So 4, yes, 4 is a perfect square. Awesome. 4 breaks into 2 and 2. 9, okay, 9 is here. 9 breaks into 3 and 3. Awesome. Is this number divisible by 2? It is. It breaks into x and x. Well, how do I know if I can keep going? Because all of this works. This has to be subtraction. This then breaks into, the fronts are the 2 x's, the backs are the 3's, one's positive and one's negative. I'm going to go over another example. 16x squared plus 9. Just another example. And I'm asking myself, can I factor this? So the first thing I do is I look at the numbers. Is 16 here? Yes. Is 9 here? Awesome. So this breaks into 4 and 4. Wonderful. This breaks into 3 and 3. Awesome. Is this divisible by 2? Yeah, I can break it into 2 equal parts. Why can I not go any further? Because it's not subtraction. Let's try one last piece. Ready? 25. X to the third minus 4. Look at your list. Is 25 and 4 on the list? Yes, so this breaks into 5 and 5 and 2 and 2. I have subtraction. Everything's looking good, but why can I not move any further? Anybody, why can't I move any further? Is this divisible by 2? Okay, so when we're working with squares, this has to be divisible by 2. So those are just a quick reviews. When can we factor? This is called a difference of squares. When can we not? So let's look up here. I need to test this and say, can I go any further? Is 1 on the list? You look at here. Look at your list. Is 1 on the list? Is 5 on the list? I have some students, they say yes, and they say, see, 5's right here. We're looking to the right side of the equal sign. 5's not there. This is as far as I can go, and we're done. Thank you for working so well together. Example number 2. So again, you're referring to factoring expressions. Number 3, I'm just giving myself a little more space to do this problem. The first thing I have to ask myself, is this currently going to be in standard form? So that means, is the exponents on the variable lined up? So to the third, to the second, to the first, and when there is no variable, to the 0. Awesome. Please underline the first 2. So this goes back to your number sense. What is the largest number you can factor out of 2 and also out of 4? The answer is 2. And then I have to ask myself, okay, I know this is like 3 n's and this is 2. What's the most I can take out of these first 2? I can take 2 out. Put parentheses down. You're not going to answer this, so this is just a hypothetical question. In my mind, I'm saying to myself, if I distribute this, that means I multiply. I'm going 2 times what is 4? That's what I'm saying to myself. I'm distributing in my mind 2 times what is 4, and the answer is 2. I need a total of 3 n's, and I only have 2. That means I need to add 1 more on, or attach 1 more. Okay, I'm going to go to the second distributing operation. 2 times what is negative 2? 2 times what is negative 2? A lot of students make a mistake and they put a 1. Now the number 1 isn't wrong, but they forgot to put a plus or minus. In order to come up with a negative 2, you have to put a negative sign. I want 2 n's, and when I distribute, I have the 2 n's right here. Whatever's in parentheses, you're going to put it in back and you're going to copy and paste it with a really light question mark in front. Bless you. Now, if we can keep factoring, it's possible we can't factor this, but if we can, there's going to be a magical number here that works for both. So come up here, and I want you to circle the top two along with the sign in front. And I'm going to think to myself, what number times 2 gives me a positive 2? What number times 2 gives me a positive 2? That's going to be a 1. But why would I still be wrong right now? I don't have a sign. Should be a plus or minus. Now, if this works, it has to work for both. So I'm going to check using distributing. So I multiply, so I get a positive 2 and an n. Okay, that's what I want. Awesome. I distribute. 1 times negative 1 is negative 1. This works. Now make that half court, 50-yard line, midline, whatever you want to call it. And we have a front half and a back half. Every time we should see something in common. And what's in common is what's in parentheses. We write it down one time. And we make a parenthesis in back. What goes in this parenthesis? You ask yourself, what's in front of the first parenthesis? 2n squared. What's in front of the second parenthesis? Positive 1. I know I can't factor anything other than 1 out of 2 and 1, so that can't be simplified. And then I ask myself here, okay, this is divisible by 2, but like there's so many things wrong here. Like this isn't subtraction. Yes, I could break this into 1 and 1, but this is not a perfect square. It's not on the list. I can't go any further. That is my final simplified answer. And when I say answer, I just mean we just rewrote it. We rewrote it correctly in a different form, in factored form. Please look right now at example number 3. Example number 3. So the first thing you ask yourself is this in a form where it's called standard form? Highest exponent on the variable, 3, 2, 1, and no ends. It is. Underline the first two. And then we're only going to worry about the value. What's the largest number you can factor out of 12 and also out of 4? 4. There's 3 ends here and there's 2 ends over here. What's the most you can take out of both? You take 2 out. So hypothetically here, I'm asking myself, 4 times what value equals 12? 4 times 3 equals 12. I need to end up with 3 ends. Right now I only have 2, and means I need to attach 1 more. 4 times what quantity is negative 4? 4 times what quantity is negative 4? The answer is negative 1. It's very important you have a sign in front and that it's the correct sign. Now I need 2 ends and I have them when I distribute. So when I combine by multiplying negative 1 and 4n squared, I ended up with negative 4n squared. Awesome. Take whatever's in parentheses, write it in back, and put a really light question mark right here. If this is factorable, using the method factoring by grouping, then there's this magical number here that when I distribute, I end up with, please circle, these last 2 terms. What value times 3n gives you a positive 9n? If you just write 3, you're wrong. Why would I be wrong? I just put a sign in front. Okay, great. Okay, so I have positive 9n. Wonderful, got that. And then I have a negative 3. Wonderful. Okay? Again, break this in half so you have a front and a back. What do they both have in common? They have a 3n minus 1. That means what's in parentheses. And you only write it once, not twice. What's in front of the first parenthesis? 4n squared. What's in front of the second parenthesis? Plus 3. Now, I need a last check. Can I simplify further? So I can't factor anything out of 3 and 1. We're good. Okay, this breaks into 2 and 2 because it is a perfect square. 4 breaks into 2 and 2. This is divisible by 2, but there's 2 things. This is not a perfect square, and this is not subtraction, so I am done. So I'm going to go through example number 4 while students are working. I cannot factor out a value other than 1. So whether you put 1 or here is really, it's up to you, but I can take out 2 x's. 4 times 1 is 4. I need 3 x's, so I attach 1 more. 4 times negative 1 is negative 1. Oh, sorry, 1 times negative 1 is negative 1. I need 2 x's, and I have that when I distribute. Copy and paste this in back, putting a really light question mark here. What times 4x, what magical number gives you a positive 12x? So I think positive 3. Let's check. Yep, that works. And is positive 3 times negative 1? It is. So I split it in half. I write down the parentheses 4x minus 1 in front of the first and in front of the second. This cannot be reduced here. Okay, so this is divisible by 2. This breaks into 1, 1, but this is not subtraction, and this cannot be broken down any further. This is my final. I'm going to show you 2 different ways to do number 5. The first way is you recognize that each of these values is divisible by 2. And so you would factor to 2, and you'd be left with 3mn plus 4m plus 21n plus 28. And then this is the part that you would work with, and we'll bring down the 2 at the end. So you would underline the first 2, and you'd recognize you can't factor out any value other than 1. And the most you can take out is 1m. 1 times what is 3? You need a 3mn. Well, you have a 3 and an m, but you're missing the n. 1 times what is 4? 4. You need a 4m, and you have that when you distribute. You copy and paste in back, and put a question mark here. What times 3 gives you a positive 21n? That'd be a positive 7. Okay, 21n, good, and positive 28. This is my break. I write down what's in parentheses, 3n plus 4, and then what's in the front, and what's in the back, and then I bring down my 2. This is the way I used to always teach it. What I recognize now is that fewer students have natural number sense, and so I have found that most students have more success by doing the following. We're going to get the same answer at the very end, but instead of initially reducing, they're going to reduce at the end. If you recognize this, go ahead and do it how I would say the traditional way. Otherwise, let's do it this way together. You were just watching still. I look up here and I ask myself, what can I factor out? So what's the largest number that comes out of 6 and also out of 8? That's going to be a 2. And I can also pull out an m. 2 times what is 6? I need a 6mn. Well, I have a 6m. I'm missing the n. 2 times what is 8? And I need an m. Okay, there is 8m. 3n plus 4 with a question mark. What quantity times 3n gives you a positive 42n? 3 times 14, and it has to be a positive sign. 14 times 3 with an n is positive 42n. And 14 times 4 is a positive 56. So I'm going to break this apart. I have a front side and a back side. They both have a 3n plus 4. Now in front of the front is a 2m, in front of the back is a positive 14. How are we still going to end up with this? I can't factor anything out of a 3 and a 4, other than 1, but 2 and 14, I can factor out a 2. And what would I be left with? 1m plus 7. How did I do that? Divide by 2, divide by 2, and then this is the other parenthesis. Now, if you did not know this, when you say a times b, it's the same thing as b times a. So this is the exact same thing as 1m plus 7 times the quantity 3n plus 4. The order you write the parentheses, whether one's in front or one's in back, ultimately doesn't matter. So these are the exact same answers. You can factor right away from the beginning and move forward, or you can wait to the very end, and then when you check by simplifying, you get the exact same answer. The majority of this class chose to simplify at the end. That's what I'm going to do. But if you personally recognize that you can already factor something out, then go ahead and do that. I'm underlining the first 2. I can see it's in standard form. And I ask myself, what can I factor out of 15 and 30? And it has to be the largest number. Now, if you don't choose the largest number, at the very end, you just need to do a little more work with simplifying. So I'm going to factor out a 15 because I know 15 divides nicely into 30 and into 15. And I recognize I can take a maximum of 2 n's out of both terms. 15 times 1 is 15. I need 3 n's. I have 2. I need 1 more. 15 times negative 2 is negative 30. I need 2 n's, and when I distribute, I already have those 2 n's. Now I'm going to copy and paste what I just had in parentheses, and I'm going to make this really light question mark. I'm looking to see, is there a magical number that I can choose that when I distribute to the 2 terms in this back parenthesis, this is what I end up with. So I'm saying to myself, what times 1 gives me a positive 12? If I write down 12, that is wrong. It has to be a positive 12. So positive 12 times 1 is positive 12, and here is an n. Bless you. 12 times negative 2 is negative 24. So I was able to achieve both of these with this magical number. Now make this division between the front half and the back half. And I'm going to pull out here, I'm going to pull out what they have in common, and that's always going to be the parenthesis. And I'm going to write what's in front of the first parenthesis and what's in front of the back parenthesis. Now, nothing I've done is wrong, but if something's going to be factored, it has to be fully in simplified form. So I need to go back and analyze this. Can I divide something out other than 1? Nope, so this parenthesis is good. What can I divide out here? What is the largest number you can divide into 12 and also into 15? Is it 3, 4, 5? What is it? 3. So I'm going to divide each of these by 3. So 15 divided by 3 is 5. 12 divided by 3 is 4. And again, whether you put this parenthesis in front or in back, it does not matter. I cannot go any further here, even though this is divisible by 2, and even though this is a perfect square, 5 is not a perfect square, and I do not have division. Okay, so I'm going to start by recognizing that each one of these 4 terms, I can take a maximum of 1x out. And when I do that, I'm left with 6x to the third. Why? Because this gives me 6x to the fourth when I combine, plus 3x squared. Again, this gives me x3x to the third, minus 24x minus 12. And now this is what I'm used to working with. If you recognize that you can divide all of those by 3, then factor out a 3. Otherwise, like I said, I teach it now differently than I used to because of students' number sense being less than it used to be. So I'm going to go ahead and I'm going to underline the first 2. And I'm going to ask myself, what's the largest number I can factor out of 6 and also out of 3? That would be 3. The most x's I can take out would be 2. So mentally, I'm asking myself, 3 times what is 6? And the answer is 2. I need 3 x's, so how many more x's do I need? 1 more x. 3 times what is 3? If I put down a 1, I am wrong. What do I need to put? A sign in front of it. In this case, it needs to be a positive 1. Okay, so let's just check real quick. Okay, 6x to the third, wonderful. 3x squared, great. I take whatever's in parentheses, I write it in back, and I put this really light question mark, dotted question mark in front. If this is possible, there's a magical number that I can distribute to 2x and into positive 1, and I end up with these 2. So in my mind, I think, what times 2 is negative 24? What times 2 is negative 24? The answer is negative 12. If I multiply, I end up with negative 24. If I multiply, I end up with negative 12. Split this so we have a front half and a back half. They both have the parentheses 2x plus 1. In the front parentheses, I have 3x squared. And in front of the back parentheses is negative 12. Now, I'm going to bring this down later on, but first let's look at this. Can I factor out anything other than a 1? I cannot. But here I can factor out a 3. Because I didn't factor it out right away, it happens at the end. So I factor out a 3 to get 1x squared divided by 3 minus 4. So if you're lost, I just took this and factored out a 3, and this is the other parenthesis. Okay, so I've got another step. I can't do anything here, but what about this? Is this a perfect square? Breaks into 1 and 1. This breaks into 2 and 2. This is divisible by 2, and I have subtraction, so I'm going to leave 2 parentheses here. And this is what we practiced at the very beginning when I did those 3 practice problems from Tuesday. The 1s and the x's are in front. The 2's are in back. 1 is positive and 1 is negative. I just took this quantity and I factored it further. Is it necessary? Absolutely. I cannot do anything with 2x plus 1. And when I bring the 3 down, it's now time to bring down that initial x that I factored out. So I'm working through example number 8 right now, giving the students in class a chance to see this. If you are done, you may look up. If you are confused, you may look up to the board, and I will work through example number 8 at this time. Example number 8. All right, so you may recognize you can factor out a 2. You may recognize you can factor out an m. All of that would work. There would be nothing wrong with that. In fact, that's how I initially would have taught this years ago. But right now when I look at this, I go, okay, what's the most I can take out for m's? I can take out 1m. And what would I be left with? And maybe even I want to take out a 2. Again, you can get through this without doing this. But I'd be left with 3mn plus 1m plus 18n. Please don't talk when I'm talking, plus 6. This is one way to do it. And then this is what I focus on. In the first 2 terms, I can take out a 1m. I'm left with 3n plus 1. 3n plus 1. What number times 3 gives you an 18? Positive 6. 6 times 1 is 6. Please don't talk when I'm talking. In the front and the back, you have a 3n plus 1. In the first part is a 1m. In back of the second parenthesis is a 6, and we got to remember about the 2m that came down. There's more than one way to do this. Who did it a different way and got the same answer? Who did it a different way and got the same answer at the end? Did you choose not to take anything out initially? Is that correct? Okay, so an alternative to this is to look up here and say, I'm not going to take anything out. And as long as you try to simplify at the end, we should be okay. So right here, the most I can take out is a 2 and an m squared. I'm left with 3n plus 1. I copy and paste it. What times 3 is 36? A 12. So 12n, oh, and I got to attach an m. 12m times 3n is 36mn. 12m times 1 is 12m. All this is working out. What do they have in common? A 3n plus 1. In front of the first part is a 2m squared. In front of the back is a 12m. All of this is good. No math that I've done is wrong, but in order to be factored, it has to be fully in simplified form. The first parenthesis is fine, but the second parenthesis, I can factor out a 2, and I can take out an m. So when I divide this by 2m, that means 2 times what is 2? I need 2 m's, that means I need 1 more. Dividing this by 2m gives me a 6. So I just factored out a 2m out of both, and I bring down the other parenthesis, and I get the exact same answer. Again, whether you put the quantity 3n plus 1 in front or in back, these are equivalent. They are all equal to this original expression. All right, what are we going to do here? We have 2 different choices. One, some students may say, I recognize this goes into 3 and 3 and 9 and 9. This is divisible by 2, x and x, and y. Can you raise your hand if this is what you did? Nothing wrong with that. So the 3x's go in front, nothing wrong with that. The 9's going back, one's positive, one's negative, but this would not be right. It's not, we're not wrong, but we're not done. What do I still need to do? I need to recognize that each one of these, what can I do? I can factor to 3. So when I divide by 3, I get 1x plus 3y. I have to do the same thing here. Divide by 3, 1x minus 3y. Oh, sorry, yep, there we go. And then the 3's out front, we're going to multiply. So 3 times 3 is 9. Again, this is not the way that I would have taught years ago, but number sense generally is not as good as it used to be. We get the same answer. I personally probably would have factored out a 9 right away. It would have looked like this, and then broken down into 1 and 1, 3 and 3. This is divisible, so x, x, y, y. We get the exact same answer in the end. Okay, here is your next problem. Are you ready? Here we go. 4x squared minus 4. You have 15 seconds. Go. I would have probably just factored out a 4 right away because I recognize that. And then that breaks into x plus 1 and x minus 1. But you didn't have to do that. If you recognize that this is a perfect square, 2 and 2, this is divisible by 2, and we have subtraction, you can do the step, but you have to then simplify by pulling out 2's. These two values then are multiplied to have a 4. Okay, we're going to throw another one at you to see how well. I want you to flip back right now, look in your notes. And I want you to find, I got to find the right page number for you. Please find this page. I want you now to look right here. Look at this. Okay, ready? We're going to do one more problem, only one more problem. Here it is. So right away when I see a 3, I think cubes. Right away when I see a 3, I think cubes. Is this on the list? So I'm going to factor out a 3. 1x cubed minus 8. And I want you to continue to move through this. The bell's going to ring shortly.